Kia ora Year 12 and Year 11. This is the third lockdown probability video, and in this one I'm going to look at tree diagrams, but when we've got sampling without replacement. So if you're working out of the Walker workbook, these questions come up about halfway through the tree diagram questions, and there's one in there about grandma's lollies. So this question is a little bit the same, but I've changed it around. So this question is about your granddad who's got a big jar of chocolates in his living room, and you can't see into the jar, and all of them are the same size. So the chocolates are all Rose's chocolates, and there are 30 of them, and these are the flavours in the jar. So there are 13 Turkish Delight, which personally I find disgusting, but other people really like. There are 7 White Raspberry, and then there are 10 Caramel Deluxe, and you're allowed to choose 2 of them. So hopefully as soon as you see that question, you should now be thinking that we're going to use a tree diagram to find out some probabilities. And we're going to do that because there's a kind of order in what's happening. You're picking the first chocolate, and then you're picking the second chocolate. But most importantly, you're picking the chocolate, presumably you're eating it, you're not replacing the chocolate. So this means we have to be a little bit careful with our tree diagram. So I'm going to start by showing you the questions I'm going to do in this video. First of all, we're going to draw a good tree diagram showing the situation, and then we're going to find a bunch of probabilities. So let's start by thinking about what the tree diagram will look like. So you should draw this in your book. In fact, if you can try and do it now, pause the video and have a go before I do it, and just think about what it means not to have replacement of the chocolates. Okay, so the first chocolate will have 3 possible things, right? So Turkish Delight, White Raspberry, and what was the other one? Caramel Deluxe. We know that there are 13 Turkish Delights. Let's just check. Yeah, 13 Turkish Delight, 7 Raspberry, and 10 Caramel. So that's 13 out of 30, 7 White Raspberry out of 30, and then what's the rest? Oh, 10 out of 30 Caramel. This is about the only time in my life that I don't simplify fractions, so leave that 10 out of 30 as 10 out of 30. Don't make it into 1/3. Now let's think about the second chocolate and what's going on. Well, the difference now is that we've only got 29 chocolates left, and the probabilities are going to depend on what this first branch was. So if the first chocolate we took was a Turkish Delight, that means there are now only 12 Turkish Delights left out of 29. There are still going to be 7 White Raspberries out of 29, and there will be 10 Caramels out of 29. For the second chocolate, if the first one was a White Raspberry, things are a bit different. So we have TD, WR, and CD. And the probability here for the Turkish Delight one is going to be 13 out of 29 because the first chocolate was a White Raspberry. That means that the White Raspberry probability will be 6 out of 29 and the Caramel Delight will be 10 out of 29. And we've got the same idea here for the Caramel one. So we're choosing now from 29 chocolates. There are still 13 out of 29 Turkish Delight. There are 7 out of 29 White Raspberry, but there are only 9 out of 29 Caramel Delights. So the best way to work with these is to just keep everything in fractions, and we're going to multiply along the branches as usual. So the probability of TD and then TD will be 13 over 30 times 12 over 29, and so on. TD, then White Raspberry, will be 13 over 30 times 7 over 29, and so on. And they're all going to add up to 1. So I'm not going to fill out the rest of those probabilities because that would be really, really boring, but that's what we're going to be using when we answer the 5 questions up here. So pause the video again and have a go at those 5 questions, and then I'm going to work through them. Okay, question 1, the probability of 2 Turkish Delights. Well, it's going to be the 13 out of 30 the first time times the 12 that are left on the second go. So that works out to be 156 divided by 870, whatever that number is. I actually didn't work that out as a decimal, but you could do that. If you work that out as a decimal, take it out to 4 decimal places. The next question, the probability of 1 Turkish delight and 1 white raspberry. Okay, so we need to be a little bit more careful here because there are 2 ways that this could happen. The first way is that we get the Turkish delight first and then the white raspberry. Or we could have it the other way around. We could have the white raspberry and then the Turkish delight. So for this one, we're going to have 13 over 30 times 7 over 29 plus 7 over 30 times 13 over 29. That gives us, timesing that all together, I know most of you hate fractions, but they really do come in handy here. So we've got 91 over 70 plus 91 over, 870. And that gives me 0.2092, and that's going to 4 decimal places. Right, let's go on to number 3. The probability of 2 different chocolates. Right, there's an easy way to do this, and then there's a hard way to do it. So the probability of 2 different chocolates is a pain. We've got 9 different things going on here, right? So which ones are going to give me the 2 different chocolates? Let's just highlight in orange. Which ones will give me different chocolates? This one here, 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 and this one here. So that's 6 things we have to add up. So that's just a pain in the neck. The other way to think about this is that the probability of 2 different chocolates is the complement of this event. It's 1 minus the probability of getting 2 the same. So now let's look at how many ways there are to get 2 the same. Well, obviously, there are 3 kinds of chocolate, so there are 3 of those probabilities. So 2 the same, let's just choose a nice colour. So this purple colour, 2 the same. Here's my first one the same, here's my second one the same, and here's my third one the same. So the probability of 2 different is equal to 1 minus the probability of 2 the same. So that's equal to 1 minus 13 over 30 times 12 over 29 plus, for the white raspberry, 7 over 30 times 6 over 29 plus 10 over 30 times 9 over 29. And adding those up, we get 1 minus, and we've got a common denominator here of 30 times 29, which is 870. And we've got 156 plus 42 plus 90, which gives me 1 minus 288 over 870, or 0.6690. Okay, so that's the probability of getting 2 that are different. So along the way, we worked out the probability of getting 2 the same, right? So the probability of 2 the same is that 288 over 870, which is 0.33103. Now, I'm writing that down because we're going to use that, I think, if I remember rightly, in the next question. So just going over this one, we've just found the probability of getting 2 different chocolates is 0.6690. Right, let's go back up. Okay, we are going to use that probability. If you choose 2 the same, what's the probability that both are white raspberry chocolates? So this is a conditional probability, right? Because I'm only interested in those times where I got 2 the same. So the probability that I'm trying to find is this. I'm sorry, got some background noise here. Right, so it's the probability that we get 2 white raspberries given that we've got 2 the same. If you're not comfortable with this, it's probably because you haven't watched video 1 and video 2 where I do conditional probability. So the way we find a conditional probability is that we limit ourselves to the cases where we've got 2 the same, and then we say, well, when have we got 2 that are the same and white raspberry, white raspberry. Well, we know the probability of getting two the same is 0.33103. We know that from up here, right? We worked that out in there. And the probability of having them both be white raspberry was the 42 over 870, which we worked out earlier. So that works out to be 0.048276 over 0.33103, giving me a final answer of 0.1458. Okay, so there we go. That's the final one. Now I've got one question left to do. I'm not sure if you guys can hear the drumming in the background there, but it's pretty loud here. So if you're allowed to choose 3 chocolates, what's the probability that they are all the same? So here we could draw a massive tree, or we could just imagine that tree in our heads. Okay, so 3 chocolates, what's going to happen? So if they're all the same, the number of white raspberries available is going to drop each time. So if we're choosing 3 chocolates, we can just do it with the tree diagram in our head. Right, so it's the probability of, first of all, we've got the Turkish Delights. So 13 out of 30 on the first go. Then there are 12 left on the second go out of 29 chocolates. And there are 11 left on the third chocolate out of 28. Plus the same thing for the white raspberry ones. 7 of them to start with, 7 out of 30. Then if we've eaten one of them on the first go, 6 out of 29, and then 5 left out of 28. Next, we've got the Caramel Delights. We started with 10, and then we had 9 left out of 29, and then we had 8 left out of 28. So if we work all of that out, you can do that on your calculator, and you'll get a final answer of a decimal answer. If you do the fraction add up first, you should get this 2,646 divided by 24,360, and that gives us a final answer of 0.1086 to 4 decimal places. So there you go. Thanks for watching. There are often questions at level 2 and at level 3 in probability about sampling without replacement. So the main thing you need to do is be thinking about whether it applies to your fact situation. So this one here, it was pretty obvious because you were choosing chocolates and they got eaten. But you'll see more examples like this as you work through the workbook.